Good day, I am Nina Santillana, and with me is Rachel Carza, and we will be presenting our dyoe entitled Application of Snell's Law in Determining the Speed of Light in Gelatin. To be able to perform our experiment, these were the materials that we used: a laser beam, laser pointer or laser level, a mounting device which is optional, a protractor, clear gelatin, plastic containers, and salt. For this experiment, we have two main objectives. First is to determine the speed of light in gelatin with the use of Snell's law, and to apply Snell's law and the definition of the index of refraction. So this is the procedure for our experiment. First, make gelatin according to the box. For this experiment, there will be three setups. First, the container with plain gelatin. Second, gelatin with 1 tablespoon of salt. And third, the gelatin with 2 tablespoons of salt. Second, mix the salt and the gelatin while it is in a liquid state in separate containers and freeze until the gelatin becomes firm. Third, you can then opt to remove the gelatin from the clear plastic container or measure inside the said container. However, you must take note to make sure that the container does not have a lot of condensation as it may affect the measurement. Fourth, point the laser beam through the gelatin at any angle. In our case, we use 50 degrees, and use the angle in which you point the laser beam as the angle of incidence. Then look for the angle in which the laser passes through the gelatin and label that as the angle of refraction. And lastly, find the speed of light in gelatin. Using Snell's law, you can calculate the index of refraction and use it to find the speed of light in the medium.
Here presented is the experimental setup used for this study. As shown, the researchers will be utilizing a laser and gelatin. The laser will be placed at a certain angle, also known as the angle of incidence. This is the angle between the laser and the normal line. When the light of the laser is pointed at the medium, which is the gelatin, the light will refract and create the angle of refraction. The angle of refraction is the angle between the normal line and the light departed from the medium. The researchers conducted the same method to 3 gelatin samples: plain gelatin, gelatin with 1 tablespoon of salt, and gelatin with 2 tablespoons of salt. For uniformity, we set our angle of incidence to 50 degrees. For the plain gelatin, we were able to obtain an angle of refraction of 40 degrees. For the gelatin with 1 tablespoon of salt, we obtained 29 degrees, while for the gelatin with 2 tablespoons, we obtained 23 degrees for the angle of refraction. Here is a summary of results that we obtained from measuring the angle of refraction. We conducted the same experiment separately, that's why there are two sets of data. As mentioned, the angle of incidence that we use for all samples is 50 degrees. We observed that the angle of refraction decreased on the gelatin samples that have higher contents of salt. In order to measure the speed of light in the gelatin samples, the researchers made use of Snell's law. It is used in finding the relationship between the angle of light before it goes into and after going through a medium. Snell's law is defined by the equation incident index sine angle of incidence equals to refracted index sine angle of refraction. Here are the equations derived from the Snell's law to be able to compute for the index of refraction and speed of light. The index of refraction can be computed by sine angle of incidence divided by sine angle of refraction, while the speed of light can be computed by the equation 2.9 times 10 raised to the 7th power divided by the index of refraction. Using the equations mentioned in the previous slide, we were able to obtain the following results. The speed of light in the gelatin decreased as the amount of salt content in the gelatin increased. Therefore, the plain gelatin has the fastest speed of light in the samples. Same with the index of refraction. The values decrease as the amount of salt increased.
So now for our conclusions. We can conclude that the angle of refraction decreases as the amount of salt increases. An increase in salt content affects the speed of light and also affects the density of the gelatin. The denser gelatin, which are the setups with salt content, had a slower speed of light and had a narrow angle of refraction. And the less dense gelatin setup, which is the plain gelatin setup, had an increase of speed of light and had the least amount of refraction.
For our recommendations, we recommend using different angles of incidence and comparing the angle of refraction with gelatin containing salt and sugar. We also recommend exploring by mixing other compounds into gelatin. And this concludes our presentation about the application of Snell's law in determining the speed of light in gelatin. Thank you and have a great day ahead.